Alright, in this video I'm going to be looking at the first FRQ question from the Calculus Review for Chapter 3, and I'm going to be looking specifically at letter D from this question, which is asking us to sketch what we think f looks like based on f prime. So we have to look at the original function based on that derivative, right? Alright. So if we're looking at the graph of f, we have to make some interpretations based on the derivative. The first things that we're going to be doing are taking a look at the specifications that the problem's given us. First off, it's told us that we only want to look at the interval from -4 to 0. And the second thing that it's told us is f of -1 equals 0. And this is important because of what I said in the last video. Remember, when we look at f prime, we don't actually know anything about the y values of our original function because we can only get y values from the equation for f of x or from the graph of f of x, and we don't have either one of those things here. We're only looking at the derivative, so we don't know about the y values until they tell us specifically what they are. So at this point, what I'm going to do is set up my sketch curve. So I'm going to go ahead and set up my axes here. I don't have very much to go on, but I do know that I only want to look from -4 to 0. A little messy, -4, -3, -2, -1. And I do know that f of -1 equals 0. So I can plot that point right here. That's the first thing I'm looking at. So this is going to be the pivotal first step for setting up this equation. I don't want to graph too much. We only care about this little segment here. It's like if they give you a sheet with 20 homework problems on it and say only do 1 through 5, you're not going to look at the other 15, right? We don't care about anything else that's going on here, just this section. So the first thing that I always start with is everything I can get out of just my first derivative. And if you recall, the first derivative tells you everything about increasing, decreasing, minimums, maximums, critical values, right? And in order to find all of those things, what we look at is we look at the y values of the graph of f prime, right? These are all things we can see on here just by looking at where it's above the x-axis, where it's below, or where it's equal to. So critical values come from, if you're thinking about an equation, they come from when you set your first derivative equal to 0, right? So we know our first derivative is equal to 0 when we look at the 0 y value, which is right here on the x-axis. So my critical value that's inside my interval, the only thing I care about, is going to be that -1 right there. And we have something specific happening at this -1. It's not just a critical value. What I figured out in the last section of this, when I was looking at Part B, I found out that I had a positive slope, positive y values, and it changed to a negative slope, negative y values. So right here at -1, I actually have a maximum, which I can kind of sketch onto my graph, showing that on either side of this point, I'm going downhill. I don't know exactly what's happening, but I'm going downhill. Now, I have positive y values all the way from -7 to -1, which means all the way from -7 off my graph to -1, I have positive y values, I have a positive slope. So when I'm reading from left to right, I'm going to be going uphill that whole time. So I drew my dotted line just a little bit because I wasn't sure what's going on, but now I'm positive that I'm going down in some way up until that point, if I'm starting from -1. When I read from left to right, obviously, that's going uphill, right? Because we have a positive slope, we have positive y values. And then over here, from -1 to 0, remember just inside that interval I care about, I'm below the x-axis, which means I have a negative slope. So all the way until this 0 on the x-axis, I'm going downhill somehow. So I know that I'm increasing here, I know I'm decreasing here, I know I have a maximum, I don't have any minimums, and I've listed all of my critical values, which means I'm done with f prime. I don't have to worry about looking at the graph of f prime for its y values anymore. Now I can start looking at f prime for concavity and points of inflection. And remember, those things come from the second derivative. And if I'm looking for anything from the second derivative, like concavity or points of inflection, I'm not actually going to look at the y values. Remember from the last lecture, the slope and the derivative are the same thing. So if I'm looking for the derivative of my derivative, I'm looking for the slope of my derivative. Where is it increasing? Where is it decreasing, right? And we're just going to be looking on this interval from -4 to 0. I'm going to be looking at the slope of my original function, or of my first derivative here. So I have a positive slope from -4 to 3. My f prime graph is going uphill. If I have a positive slope of f prime, that means I have a positive derivative of f prime. That means I have a positive f double prime. If I have a positive f double prime, that means I have a positive concavity. I am concave up like a cup, right? So from -4 to -3, I still am increasing, but instead of a straight line or curving down like that, I'm going to be curving up like a cup, okay? And then from -3 all the way to 0, my slope is going downhill. I could ride a sled down that, right? So if I'm going from left to right and I'm going downhill from -3 to 0, that means all the rest of my graph from -3 to where I end over here at 0, this is all curved down like a frown, right? So over here, curving down. So what they didn't ask me, but what I know, is that I changed concavity right here at -3. And if I look at my f prime, I can see that a change in concavity is a change in slope, where I went from a positive slope to a negative slope, which means I went from a positive second derivative to a negative second derivative. So even though I'm not listing my POI as a coordinate, I know that I have a point of inflection right here at -3. All right, if we have to justify this, now remember on the FRQ you don't have to justify until it tells you to, but we do have to justify for this review packet anyway. If I want to justify what's going on with the change in my curve here of f of x, I can say several things. I can say that I know I have a maximum at x equals -1 because f prime changes from positive to negative y values, which we talked about in the last section. I can also say that I know I am increasing from -4 to -1 and decreasing from -1 to 0 because my slope, because my y values were positive and negative. I'm just going to write respectively, which means that my positive was where I was increasing and my negative was where I was decreasing. Let me move it so you can actually see it. If you're going to write this as a justification on your exam, it's probably a good idea to just go ahead and write that out in separate sections, that it was increasing because the y values were positive, and it was decreasing because the y values were negative. Now, that wasn't all I talked about when I graphed this. There was another thing I looked at, and that was my concavity. So right over here on the side, I'm just going to go ahead and justify my concavity. I knew that I was concave up from -4 to -3 because the slope of f prime is positive. There we go. And I knew I was concave down from -3 to 0 because the slope of f prime is negative. Okay? So here we've talked about our increasing, decreasing intervals, right? We had to talk about that maximum that we found that was at the point that they gave us, -1, 0. We had to talk about the concavity, concave up and concave down that we got from the slope of f prime. And all of these things happened all inside this one graph. So just looking at this graph, if you look at all the different things you can get from the first derivative by looking at the y values, things you can get from the second derivative by looking at the slope, they will tell you everything you need to know about how to graph that original, okay? All right, well, that does it for question 1. We can go ahead and take a look at question 2 in the next video.